Okay. um, Figure shows the blackbody radiation curve at a given temperature. Consider the following statements. Okay, at a higher temperature, lambda m would be lower, intensity would be higher, velocity of the emitted radiation would be higher. Let's see one by one each statements. Okay, now this says for a given temperature, let's take that temperature is T1. And what happens if I increase the temperature up to some T2 temperature? Let's draw the graph in the same let's draw the curve in the same graph. Okay, so when I draw that, I will get a graph like this. Okay, so this is T2 temperature where T2 is greater than T1. So as we can see, the wavelength corresponding to maximum temperature, right, that is now lower than the previous value, right? Let's say this is lambda m dash. Okay, so lambda m would be lower, that is true, and also we can understand this considering the Wien's displacement law. What is Wien's displacement law? He says that the product of lambda m versus absolute temperature is a constant, right? And we say that is the Wien's constant, right? So from this formula we can see that lambda m is proportional to 1 over T. So as the temperature increases, lambda m would be decreases. Okay, so lambda m would be lower, that statement is true. And the second statement, intensity would be higher. So as we can see, the intensity is higher, right? So it covers a large area, so the uh, radiation energy emitted per second is higher, right? So intensity is higher. Okay, that is also true. And the third statement, I mean the statement C, velocity of the emitted radiation would be higher. Okay, what can we say about this? Now, as we know, as we increase the temperature, the energy is increased, right? And also the lambda m, the wavelength corresponding to maximum intensity is decreased, right? So lambda m decrease means the frequency corresponding to uh, higher sorry, give me a second. The frequency corresponding to maximum intensity, I mean the peak intensity is increased, right? But even though the frequency increase, now we know this is the thermal radiation curve, right? Thermal radiation curve, the thermal radiation, it is a electromagnetic radiation, it is electromagnetic radiation, and we know the fact that all the electromagnetic radiation moves with the same speed, right? So if I consider this EM radiation spectrum, so here would be the thermal radiation, right? So even though the frequency is increased, right, the velocity or the speed is remains the same, that is the speed of light, which is 3 into 10 to power 8 meter per second. Okay, so the statement C is false, so only A and B is true. Okay.